Okay, I recognize at this point some of you are going, I did the notes, I thought I was understanding, I get what you tried to teach at the start of class today, and I still need some help. I still need kind of that GPS concept. So just kind of taking a look at these together, trying to understand how it should fit with the presentation that you looked at. So when we look at the screen, of course, the presentation is going to be a little jumpy, this presentation here. But I did want to go back and forth just to kind of show you what we're actually looking at. So what's inside our Earth? The Earth is made up of 4 layers: inner core, outer core, mantle, and crust. Those are on here. You know, there are 4 layers to the Earth's, and it's inner core, outer core, mantle, and crust. So, I mean, you've got these answers right here. It's done. Pen doesn't want to work. The part's done. You don't need to write the word done. It just is done. Crust has 2 types. It's on our screen right there, continental and oceanic. So down here, 2, continental, oceanic. Continental crust is located blank and aged blank. Oceanic crust is blank and aged blank. Here we go. Continental crust forms the land. It's pretty thick, mostly old. Oceanic crust, oceans, new, 200 million years old. So, hopefully some of you are seeing, I don't put a ton of notes in here. I mean, for me, I understand it at that point. It doesn't need to be over the top. So that's kind of what we're looking at there. 3 layers of the mantle. The mantle makes up, boom, right there, top of the screen. Mantle makes up most of Earth's mass, 67%. Inner core and outer core is made of heavy materials like, okay, we got all this information about the mantle going straight onto the core. Heavy metals like iron. Right? Inner core makes up the Earth's blank, which keeps us safe from the sun's blank. Now here is where it gets tricky. This is where you gotta, inner core spins at a different speed than the rest of the planet, blah, 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 causes the Earth's magnetic field. Without the magnetic field, we would be eradicated by the sun's ultraviolet rays. You can see, this is 2 words. And it's going to be magnetic field and ultraviolet. Wegener said that all the continents were once, okay, skip that part, continental drift theory, right? Theory that says the Earth's continents have been joined together and may have moved away from each other, first proposed by Alfred Wegener. So his theory is that they were all connected, joined. Your choice of words. The continents were once connected or joined or together. Whatever your thought is on that. Okay? Continental drift theory was developed by Alfred, just fill in the guy's name, Wegener. Continental drift theory says that the Earth's blank have all been joined together and have moved blank from each other at different times in Earth's blank. Okay? So, his theory becomes known as continental drift theory. So he says that the Earth's continents the continents, here we go, the continents started to move away from one another, causing the supercontinent to split up, been joined together, and have moved away from each other at different times in Earth's. Now that maybe isn't specifically in there, but I mean really past, we could say history, past. Okay. Wegener's biggest evidence was the blank. Fossils of the blank blank were found on different continents separated by oceans. Okay, so his biggest evidence was You had choices on this too. You could say the puzzle pieces, right? This big evidence was the puzzle pieces. You might have said his biggest evidence was the fossil record. Okay, fossil record might actually fit better because then it goes on to talk about fossils anyhow. So it's another option. Fossils of the same type, same species, same animal is specifically what's in our notes. Were found on different continents separated by oceans. So same animal, literally right here, same animal found on different continents that were separated by an ocean. This one is a word for word. Okay, Pangea is the, shouldn't even have to think about this one. We know what Pangea is. It's the supercontinent. Big puzzle made of the Earth's continents. Eventually Pangea broke apart, up, Currently our plates are blank. Create a Pangea like blank again. Currently our plates are shifting, creating a Pangea like continent again. Okay, shifting continent. So, backside. This thing confused so many people. Movement. How do they move? The convergent, divergent, and transform boundaries. Forms. What landforms do they possibly make? Example of the landform. You know how they move. Convergent, toward, divergent, apart, transform, across. Easy. Easy. Right? These form earthquakes. So let's look at the notes. What do we got? Had this. Plates move away, toward, apart, or slide. Okay? Convergent, we can give volcanic activity, mountains, rifts, valleys. So all sorts of options for divergent. The forms. Mid-Atlantic Ridge. Okay. Iceland, another one, another example. This one's got volcanic activity. Transform boundary, they create earthquakes. Forms, fault lines. Example, San Andreas Fault. Right, and that's the example given right here. San Andreas Fault, transform boundary. Convergent boundary, three types: oceanic, continental, 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 and oceanic, oceanic. And they react differently. You saw this, you know about this, subduction zones. So what do they create? Well, they could create volcanoes, they could create mountain ranges. Example given in your notes is the Himalayas. Himalayas. When oceanic and continental boundaries collide, the oceanic subduction under the continental. That one's clear. You want to add notes to it, you can. You want to draw a picture of it, what it might look like. You certainly could do that. But this is showing what that would be. Okay, under, subduction. Subduction zone is an area where tectonic plate collision. Wait, that one's not complete, right? That's not a complete sentence. Subduction zone is an area where tectonic plate collision ducks under. Okay, continental, continental plates push against each other until one converts so that the other can subduct under it, forms mountains. That one's done. That one's good how it looks. You could show these coming at each other. This one goes under, and we get mountains. Right, do a little drawing. Oceanic. When these two plates collide, one goes over the other, creating a collision zone, create a deep depression in the ocean floor. It's called a trench. So, right, here we go. Waves, got our trench coming down here. This is the thing some of you asked about in Finding Nemo, when they run across that fish that has a little light on its head. Yeah, that's an anglerfish. We have an anglerfish right here. These trenches are the deepest parts of our ocean. Scientists have explored and found species such as the anglerfish here. That is the Finding Nemo thing. Here are your pictures of the convergent, divergent, and transform boundaries. Don't forget you had to do this exit ticket and turn it in. Just do it. That's your guidelines if you need a little more connection on this exit ticket. I'm not going to tell you the answers. That's what we're looking at.